All right, we're getting there, folks. Let me be able to figure this out yet. We're getting there. Somewhere there used to be a control that let me go to full screen. Well, it's closer. Yeah, it's not the whole thing, but it's closer. Okay, we can live with that. Do we have your camera working?
Plugged in, I guess it won't work for you. I guess it said its own USB port.
Yeah,
I would think it's, since there's no instructions, I'm assuming it just sort of turns on by its own.
yeah. Nobody wants to give instructions anymore with things that are electronic. You're just supposed to know.
This is supposed to work so intuitively, it just turns on its own.
You might need to select the camera here.
What do we want to do this for next time?
Okay, we'll set
So-
this up later
Yeah, okay.
because well, it's not quite time for class, but it's getting there. Let's see if it, yeah, does update. Now, what I don't know right now. Says it's recording, okay. Except now, how do I? It doesn't look like. Anyway, it looks like it's recording. I guess I can't get gallery view because I'm the only participant. Okay, I guess that makes sense. No one else is zoomed in. So I'm assuming, okay. I actually also forgot to get one other thing. I got time to get it if I can.
So most guys have undergrad, grad students? What?
Final grad student.
Your graduate student. Your graduate student? Any other graduates? One of them.
Two of them.
Undergrad. No undergrad, that's what's grad student. Is that from Sloan or all from the engineering school?
Yeah.
Okay.
Okay, my name's Tom Eager. We'll start 2 minutes early. I'm actually on sabbatical this term. That's why I'm not here. But I have been teaching the course for 35 years in one form or another. And so I'm going to hand around a class list. Ordinarily, my secretary has this all done up on a nice thing that she called in. This morning, she wasn't feeling well, so she stayed home. So I just need your name and your email address. And that's because I have never, in the 50 years I've been at MIT, figured out the registrar system. Okay. You can pre-register or not. The only way I know who's in the class is to pass around the list. Okay, because the registrar's list is, well, it's 80% right, but I kind of care about those other 20%, and things as well. So we'll pass that around for a few days, and eventually the registrar might catch up. I still find the registrar is 2 or 3% wrong at the end of the semester. Okay, there's usually a student on there who decided not to take the class, forgot to drop it, or students who have been taking the class and didn't realize that the registrar didn't have them registered. So in any case, that's the way life goes. This is Dr. Don Baskin, and Don is, he's actually going to be lecturing live this semester starting tomorrow. And if you were on the pre-reg list, you should have gotten an email from my secretary, Maria Giovanni, who sent around a course intro, and I'll put it up in a little bit, that had the Zoom addresses and the fact that we're meeting this morning and tomorrow morning at 9 o'clock. And the next class after that will be the next Wednesday, when Dr. Neil Jenkins will be doing a module. So this course is, in fact, that's what's up there right now, is my name, Don Baskin's name and contact information. He's actually officially the lecturer in charge, but he's never had to be in charge of this class before. He will be doing 12 live lectures in this room every Thursday. Okay. Then Dr. Neil Jenkins, who's an MIT alum, you can see from his email address, he will be doing 6 live lectures on respirators versus masks. And you can say, well, what does that have to do with structural materials? I don't know. Okay. But Neil was actually an MIT undergraduate. He was a doctoral student of mine 10 years ago. He went to medical school. When he was a doctoral student, he was looking at aerosols, welding aerosols. And he's been looking at aerosols ever since. And so he knows a fair amount about masks and respirators. Seemed like an interesting topic for this time. Okay. So if you want to learn about respirators and masks, Neil is an MIT person who can explain it. Okay. And if you don't know what I mean by an MIT person, how many people are at MIT brand new, never been here before in a class at MIT? Okay, 2 of you are new. Okay, well, were you at MIT before graduate school?
No.
No, okay. And Were you?
Well, I haven't been here in person.
Oh, okay, okay, so you've taken some MIT classes. But MIT is a little bit different, and I've got some things to talk about that a little bit. As I said, I've been here for, I guess now, all but 3 of 53 years. I came here as a freshman in 1968 and couldn't get out of the rut, or whatever you want to call it. So I'm still here. Maria Giovanni, and this is on Canvas. And I have not yet learned how to use Canvas. I learned how to use Stellar, and then they changed it, and that's what they do around here. That's what administrators are good for, is changing things. There is a sign-up sheet, it's just a pad of yellow paper going around, and I explained it's because I can't trust the registrar's list to be current for about 3 or 4 weeks from now. It became a fully online class during COVID, and it returns to being hybrid in fall of this semester. I'll be doing the recitations even though I'm on sabbatical. The recitations will consist of whatever you send me you want to do, and the recitations will typically be on Mondays, Tuesdays, or Fridays. But we'll work some of those things out. We'll do that as needed. Neil Jenkins will be doing Wednesdays, and Don Baskin will be, I said Tuesdays or Thursdays. He's actually on Thursdays. They're all at 9 to 10. Did you want to say something now?
No, just
No?
okay.
Okay, fine. He'll be here tomorrow. He can say a lot. The only thing you really have, well, there's a couple of things you have to do in the class. I'll get to that slide. But mostly you have to do a 10-minute presentation. And originally that presentation, originally it was a paper, a 10-page paper, and then it had to be turned into a presentation. In this size class, 1, 2, 3, 4, 5, 6, 7, 10, 15. So this size class is adequate that we can do 10-minute presentations. And it turns out I used to kind of want the presentations to be on structural materials because that's what class is about, right? And then I learned, some students say, well, can I do it on such and such? And I finally learned that you can do it on anything you want. This is your opportunity to teach your classmates. You only have 10 minutes, okay, we'll get into that. But a lot of the students have gotten to the point where they prefer the students' presentations to the lectures. Okay, what does that say about the faculty? In any case, but I found that if it's something you really care about, you'll do a really good job on it, okay? And so I've decided, I don't care if it's on structural materials. Teach about anything you want. One student this summer did macaroni and cheese, okay? And I learned about the history of macaroni and cheese. How did macaroni and cheese get to the United States? Thomas Jefferson brought it from France, okay? And he served it in the White House. He called it macaroni pie and blah, 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 blah. And I've tried the recipe, which I think she claimed it came down from her great-great-great-grandmother, which kind of takes her back to Thomas Jefferson's time, okay? So I don't know if this is the original recipe, but nonetheless, other people have done sailboat masts, other people have done pole vaulting poles. I'll give you some examples in a little bit. Anything you want. And you can even cheat, okay? If you've done a presentation on your doctoral thesis or your master's thesis, and you want to do that, you don't even have to prepare something for this class. You can just, as long as you pare it down and say something intelligent in 10 minutes. That's all you have to do. Well, you don't have to say something intelligent. There have been a couple of people who've gotten B's in this class, okay? If you don't listen to some of the principles we try to teach you and you would completely ignore them, you could end up with a less than favorable grade. Okay. I like to call this flexibility in a stress-free environment. The administration always talks about how they're trying to reduce the pace and pressure of MIT. Well, good for you, okay? A lot of us think the pace and pressure is part of the essence of MIT, okay? That doesn't mean that you have to be in a situation where the pace and pressure start creating emotional problems for you, okay? But one of the things you ought to learn at MIT is to deal with pace and pressure. And my thesis advisor used to say, MIT teaches you to deal gracefully under pressure, whatever that means, okay? So I decided a few years ago, and we'll get into this, that I didn't like the way we teach, not just at MIT, but across the country. And I'll tell that story in a little bit. By the way, in general, I tell stories, okay? That's something else I learned about 30 years ago when I started thinking back, well, what did I learn? What do I remember what the classes I took at MIT? And I don't remember how to integrate sine x over x, okay? But I do remember the stories, okay? And so you'll find that some of the students actually agree with me. What they really remember are the stories, okay? So I teach in sound bites, stories. About 10 years ago, Professor Shu, before he's department head, asked me to, he was head of the graduate committee. He says, well, Tom, why don't you teach something other than your research specialty and stuff? So I started doing things, teaching some other things, and then I started turning things in. I found students liked, well, I actually had some things in kind of modular format, 12 lectures. You got to get 36 lectures to be a 12-unit course, okay? And so I was teaching 12-unit modules. And then I found the students kind of liked some 6-unit modules for various reasons. And I learned about 30 years ago, I was the first person at MIT ever to give credit by tutored video instruction, okay, MIT credit. This was back in 1991. What happened, General Motors asked me to teach my welding course. They had a program where you could get a master's degree if you're an engineer at General Motors. You get a master's degree at RPI or Purdue University. And you could take those Purdue or RPI courses, but they really wanted Tom Eager talking about welding because I was sort of known as a welder, okay? And so I was on a committee, John Little's committee. It was called the Do Something Committee, as most committees do nothing, right? So he called it Do Something. So we were supposed to be looking at distance education. This was 30 years ago. And so this opportunity came up. General Motors was willing to pay full tuition for like 20 students to take this course. And so MIT gave us special permission to have me teach the course. The only problem was I had to prove that my course could get credit, be worthy of credit at RPI and Purdue, okay? That an MIT graduate course was worthy of these other two universities. But I had to create a syllabus and I gave it to them and we passed. And so I started teaching my welding course. And while I was doing that, I used to tell the students, okay, this was when we had videotapes, okay? And I said, okay, we're gonna send you a videotape of 3 lectures a week. And I want everybody to ask me 1 question a week. And after about 8 or 10 weeks, I had like 2 questions from the entire class of 20 students. And then General Motors paid for me to go out to the tech center where most of the students were and to meet with them. I said, how come I don't get questions? And the students said, well, we found that if we just play the tape back on the part that was confusing, it makes sense the second time. And it turns out Stanford, who was the expert on tutored video instruction back in the 80s, they found the same thing. Students who took the course on video did better than the students in the classroom. Because in the classroom, you start to nod off. Why would you do that? Anyway, and if you start to nod off, you can always play it back and catch up on where you were, okay? And so I decided, well, the other thing is some of the students that were taking it in class at MIT would say, oh, I got to be away. I go into a conference, blah, blah, blah. And I said, well, just watch the movie. And so I determined it was worthwhile videotaping my class for the students, for your benefit. And it turns out that after 2 years, the General Motors thing, the money went away. I don't know what happened. MIT probably absconded with it. But I decided to keep on videotaping the class out of my own pocket, okay? And I would pay students, I have camera equipment to be a student in the back, and ask some student taking the class, I'd say, well, okay, if you want, I'll pay you $50 a class to come to class and set up the video camera and download it. As a result, we have all kinds of videos, about 150, 200 hours of videos. And I've had some students take the course up to 3 times. It says in the catalog, you can repeat the course as long as you take a different 36 lectures. Okay. So one undergraduate took 10%, almost all of their electives they took by listening to me tell stories, like I've just been telling you, okay? So we got, what is total quality management? I used to be in the, what's now called Leaders for Global Operations over at Sloan. But these are some of the things. What is engineering? Back in 2015, it may seem silly, but I actually went into course 3, material science and engineering, because it was the only department at the Institute that had both science and engineering in its name. And as a freshman, I didn't know what I wanted to do. Seems pretty silly, right? But that's the type of decisions that young freshmen make, okay? And after all those years, I still didn't know what the difference was between a scientist and an engineer. And so I came into the class in 2015. I said, okay, we're going to do an experiment this term. I'm going to teach you something that I don't know the answer to. What is engineering and what's science? And what's the difference between the two? By the end of that semester, I had 7 pages of quotes from various people about what science is and what engineering is. There was J. Robert Oppenheimer. Who was he? You were a nuclear engineer, one of you guess. Who was Oppenheimer?
Oh, the lab director of Los Alamos and Manhattan Project.
Yep, father of the hydrogen bomb, right? Or the atomic bomb. I don't know if he's the hydrogen. No, Teller was hydrogen bomb. Oppenheimer was the father of the Manhattan Project,
Yeah.
Science.
Little William Fatman.
Yep. So anyway, Oppenheimer, he actually didn't particularly like hydrogen bomb idea, but he said, I can remember the quote, he said, a scientist explains that which exists, an engineer creates that which never was. And Joel Moses, who used to be provost at MIT, an electrical engineering professor, says, and the Media Lab creates that which never will be. Okay? Hey, I didn't say it, Joel said it, okay? But it's probably true. Anyway, so that was one quote. I actually came up with the one that I like at the end of this semester, my experiment, where I lectured for 12 lectures on what is engineering. And we did a number of things. And actually, it's down to a 6-unit thing. But actually, a lot of students have liked trying to figure out what does it mean to be an engineer. But I came up with my quote. I actually came up with several quotes, sound bites. A scientist, let's see, seeks to increase human knowledge. Okay, looking at the Big Bang and the origin of the universe and quantum mechanics, and seeks to increase human knowledge. An engineer seeks to improve the human condition. So if you look at engineering accomplishments of the 20th century, the National Academy of Engineering came up with 20 things like clean water for everybody, okay? Or the computer chip, or efficient aircraft flight. You know, they came up with 20 of these things. You can look them up. This was 20 years ago. They came up with the 20 great accomplishments of the 20th century in engineering. And there's some other great accomplishments that are not necessarily engineering. I think the greatest accomplishment is universal education, which was something they came up with like the 1850s, that everyone in this country should have a right to an education. And we're still working on that. But nonetheless, you got into MIT, right? You still have a right to an education. Just not, in my opinion, the way they do it. Okay. Simone Belmar, who was an MIT undergraduate, not an MIT graduate student, got his doctoral thesis in fatigue of materials. He's out starting his own business, so he's not teaching the course anymore, but he did a number of structural materials modules, and you'll find all these on the web. Neil Jenkins did one, the last time I was on sabbatical in 2014 or so. He did one on, and remember, Neil has actually got an MD. And he actually gave one on non-destructive testing of the human body. Basically, what does a medical doctor do when you go to visit him? And he gave 12, I think 12 lectures on this, but it's basically the 5 senses: sight, sound, touch, smell, and what's the other one? Hearing, right? Right? Taste, yes. They do all the 5 senses. Certain diseases have particular smells, okay? You know that if you've ever had garlic breath, right? Okay, I mean, you know, it turns out, and Neil went through and explained how these are the types of things the physician is looking for. It's not terribly complex. You just have to know all this stuff. Of course, Neil's also the person who explained to me that I actually have, Neil has a PhD from MIT. He has an MD. Which one is the more significant degree in an academic sense? Which one would you put first after your name? No? PhD. PhD is actually by definition academically a research degree. An MD is just a training degree. You memorize everything in the medical book. There's no research. Okay. So Neil, having one of each, he can truthfully say that PhD is more significant. So he puts PhD, MD, okay, after his name in that order. What's more significant, a doctor or a PhD? A doctor being, you know, a science doctor. People say, do I call you Professor Eager or do I call you Doctor? Which one is higher academically? Professor, why? Professors give out doctorates. Okay, it's got to be a little higher, right? We actually have the authority granted by the Commonwealth of Massachusetts, good old Charlie Baker. We can give out doctorates. Don Baskin will be teaching in lightweighting. The color code here is blue is things for this year. And Don has been teaching lightweighting for 4 years now at MIT. And the students have really enjoyed it. Don, why don't you tell them about some of your background?
Sure. I got an undergraduate degree from the University of California, Irvine, in mechanical engineering. I grew up in Los Angeles, so that makes sense. I went to Northwestern University to get a PhD in material science and engineering. I should mention that Northwestern had the world's first material science and engineering department. It was the first time that any university took together the metallurgy department and the polymer science and the ceramics and put them all together and called it materials engineering. So it's the first department ever with for Morris Fine. Let's see here. After school, I went to work at a think tank at Chrysler in Detroit. I'm kind of a car nut and always have been. And I was offered the opportunity to work at Mercedes in Germany in their materials research lab. So I moved to Germany for about 2.5 years. And when I came back, I got my hands dirty putting real cars into production. I launched the Dodge Charger and the Magnum and the 300 and a bunch of crappy Sebring cars, etc. Let's see here. After that, I got invited to work one of Chris Shue's, Professor Shue's startups out here in Marlboro, and I've been sort of part of the ecosystem.
Did you
for the
talk
last
about
10 years.
Germany?
Huh?
Did you mention Germany?
I did.
Oh, sorry, I wasn't listening. Sorry.
Anyway, let's see here. So I worked in startups for about the past 10 years, and anyway, we can talk about startups some other time. It's a different topic. But anyway, so now I've opened my own company about 3 years ago called Spectrum Materials Engineering, and I consult on a variety of issues, including lightweighting, which I have done. But I get involved with train cars that blow up, and scooters that fall apart, and people need to figure out how to make a better mousetrap. And I'm busy doing that. And then like Professor Eager said, about 4 years ago, I started lecturing here at MIT on lightweighting, and just a little bit about the course. So that's probably what's most important here. So lightweighting is important because any vehicle, whether it's a truck or a bus or skateboard or surfboard, whatever, has to be accelerated. It's not really a vehicle. And the weight of it determines how much energy you have to put in order to get to accelerate, right? So that means that the amount of energy also that you're using, that also has to do with, say, emissions, CO2 emissions in the environment. Okay, and so climate change really has a lot to do with lightweighting. And a lot of the national labs in this country, the National Science Foundation, and Department of Transportation, the National Highway Traffic Safety Association, they're all obsessed with lightweighting because they can't figure out a way to get vehicles to use less energy. Even if a vehicle is electric, it doesn't matter. You're still somewhere along the line you're putting CO2 in the atmosphere, unless it's nuclear, or solar, or nuclear, right? Or
Wind.
wind. So and those aren't really working full time right now. So we're still burning fossil fuels. So they're very interested in reducing weight. I spent most of my career at Chrysler and Mercedes working on lightweighting, and I managed teams that design new body structures that were lightweight. And so I don't know. It's been a passion of mine ever since I was a kid. I used to race bicycles in high school and junior high school. I don't look like it anymore, but I used to be in pretty good shape. So lightweighting has always been a really topic that's I'm really passionate about. So I collected all this information. I had a client who asked me to put together a lecture on lightweighting, and I thought, what else can I do with this next? And one way or another, I got introduced to Professor Eager here, and I've been teaching the course ever since.
Right, and the students have really enjoyed it. He talks about bicycles too.
I talk about bicycles, I talk about cars, I talk about racing cars, I talk about skateboards, tennis rackets. Yeah, there's a lot of, the course is sort of half materials engineering and half kind of mechanics, solid mechanics.
Okay, so he does give the structural materials title to the course. Actually, I came up with it, but he adds it now because I haven't done it for a couple of years. Okay, student requirements. I have to tell you what you're required to do. You got to watch or come to 36 lectures during the term. And you're going to have to keep track of those. I'll tell you after. Usually 6 modules of 6 lectures each. There are some double modules that have 12 units, but hopefully you can figure out how to count to 36. Some of them only have 5, some of them have 8. Okay, what can I say? Prepare a brief outline of each 1-hour lecture, 1 or 2 lines. Okay, and there's a reason for this. I actually learned as a junior at MIT. Here's another story, okay? So for whatever reason, I decided to take 8 to 11 Introduction to Quantum Mechanics in the physics department. Why would I do this? I was a course 3 student. I didn't need to take this course. So I took it, and it was being taught by Vera Kistiakowsky. Vera's father, George, was a Nobel laureate at Harvard in chemistry. And Vera was the first female full professor in physics at MIT. She always brought her dog to class. She was a very, very gracious and kind woman, but I didn't understand anything she was talking about. Okay. And I was getting 15s out of 100 on the homeworks when the class average was 85. You know the feeling, right? You've been at MIT. And so the night before the final, which was on December 23rd, by the way, and I'd been working all semester to get an earlier one so I could get home and stuff. Didn't work. Anyway, I decided I would just take the textbook, Iceberg Foundations of Modern Physics or something, and I would just go through and figure out what the highlights were. Walked into the final, finished the 3-hour final in 1 hour and 20 minutes, walked out, got an A in the class. Woo! All of a sudden the light goes off. You mean all that other stuff they teach you in class is nothing but fluff? There's only a few highlights. And from then on, I never took notes in class again. My rest of my junior year, my senior year, my graduate class at MIT, I never took notes. I just sat there trying to figure out Now, what is his his or her basic outline? What is the theme of this? Can I write down in 2 lines what the theme is, what the highlights were? And if I did that, I didn't even study for classes, for quizzes much, okay? I just go in and take them because I remember the next semester, Professor Bever says, well, he was a very stodgy old professor, very, very nice person, but he says, well, we have a quiz coming up on Thursday and this is like Tuesday. He says, as the student says, what's going to be on? He says, well, everything since, the last quiz, which blah, blah, blah. And he says, well, what are the topics in there? And he said, I can't tell you that. And I said, and I blurted out in class, I was sort of a loudmouth. And I said, well, we already know. And he said, what do you mean, Mr. Eager? And I said, well, we covered, and I listed the 5 things we had covered because I was thinking in terms of themes. And I said, we're going to have a question on 1, 2, 3, and then either 4 or 5. And he looks at me, he said, we'll see. Well, I was dead on, okay? I didn't have to study for the quizzes. I had figured out how to study as I went. And so I've learned this actually is a very worthwhile thing for you, not for me. You have to turn it into me because I have to have some way to prove that I've graded each student individually. And the thing that was interesting to me when I started doing this, you take 2 students who watched the same 6 lectures and you read what they got out of the 6 lectures, you wouldn't believe they were the same lectures, okay? What it is everybody learns from their own experience. And what's important to you is not necessarily what's important to somebody else. But it doesn't matter. That's what you learned from that hour, okay? So anyway, so you've got to do that. The total for the whole course is only about 3 pages of little 2-liners, right? You got to prepare a 10-minute presentation on a materials topic of your choice. You got to attend or watch and critique. By watch, we will videotape your presentations. They won't be on YouTube for the whole world to see. We will have a private viewing. And if you miss a class and you've got to watch 6 other student presentations and critique them. Just like you were a faculty member critiquing a student on their presentation, you're not giving them a grade. It's supposed to be constructive criticism. Don't trash them, okay? One of the worst things a teacher can do is embarrass a student in front of other students, okay? If you're going to embarrass them, do it privately, okay? Okay, you don't want to embarrass them in front of other people. Don't say you're an idiot, okay? They may be an idiot, but go ahead. And I'd like you to explore topics and people of interest on your own on the web. That's an assignment that you can all take. Student presentations, 10 minutes maximum. We're going to try to do 3 an hour, which is a 50-minute hour, right? And that means it's really 15 minutes each. You get 10 minutes for the presentation. And if you go over 1 minute, I'll stand up next to you, smile. You can't see it through the mask, but whatever it's making. And after 12 minutes, it's only a couple of times in the last 5 years I've cut a student off. But usually they learn to do it. That also means only 10 overheads, 10 slides, 10 PowerPoints. That's a good rule. Attend and comment on questions on at least 6 other students, okay? Student presentation topics from the summer of 2020. Metal brushes in a motor, because the student happened to work on a startup that was working on something. iPhone glass is intriguing. It's got to be thin, lightweight, fracture resistant, which is not an easy thing in glass. How do they do it? It's layers, by the way. Okay. Well, they can do it. I think they're actually doing both now. Non-destructive testing, the World Trade Center collapse, which, by the way, comes this Saturday, right? Sailboat keel failures, Tesla production hell, meaning the Tesla vehicle. Coast Guard patrol boat conversion. Coast Guard decided they wanted to have bigger patrol boats, so they cut them in half and stuck something in between. Stress corrosion cracking of Navy combat ships. gotta remember this, this was from my Navy class, okay? Best on a topic of your own interest. It's your opportunity to teach others about something that interests you, even if it's macaroni and cheese. Okay, any materials topic you wish. Don't be too general. I don't want something, the old MIT quiz question joke was, define the, you're supposed to do a written essay, define the universe and give 3 examples, okay? Oh, gee. And I've had students say, well, I'm gonna talk about how you build an automobile. Oh, really? In 10 minutes? Okay, that'll be superficial, okay? Don't be too broad, don't try to cover too much, and add some of your own analysis. I actually had 2 students do pole vaulting polls, and pole vaulting polls are really interesting, okay? Did we get the student list? Oh, no, this, oh, okay. Pole vaulting poles, by the way, they take a square rather than a rectangle, and they roll it up from a corner, so that when they make their composite, which they then impregnate, they have greater thickness in the center and less on the edges, and that's where you want, that's how you want your bending moment. It's a structural mechanical design, pretty simple, but pretty clever, okay? And I just happen to have 2 students that term that were pole vaulters, okay? What other thing? Oh, grading requirements, okay. No tests, no quizzes, no finals. Okay, here comes another story. So for years, I used to get up at 4 o'clock in the morning, have a bowl of cereal. The house was dark. I would leave. I'd drive into MIT and before anyone else in my house was awake. So I'm eating the bowl of cereal and the newspaper hadn't come that morning. So one of my students had left their high school math book on the table, kitchen table. And I said, well, I'll look and see what they're teaching. And I paged through the book and it had 2 pages on differentials, 2 pages on integration, 2 pages on factorials, 2 pages on exponentials, 2 pages on logarithms. And I thought, I did not know mathematics was quantized, okay, into 2-page modules. And then I realized all they're doing is teaching them to take the SATs, okay? It had nothing to do with teaching math. It had to do with helping them get a good grade on the SATs. And then over the years, I thought, this was 25 years ago, and I thought, the MIT students already know how to take the SATs. You wouldn't be here if you couldn't take the SATs or the GREs or whatever. They don't even make you take the degrees anymore. So you got to give me a proposed presentation topic. That's supposed to be 9/17 by the 17th of this month, okay? There's no issue. So just send me an email and say, I'd like to talk about how Chrysler builds cars, and I will reject it, okay? And tell you, well, why don't you get down to a specific Chrysler vehicle or something, okay? And I will try to help you find a more appropriate topic that's more manageable in 10 slides. And then you're free to go off and do whatever you want. And if you say, I want to talk about one student 2 semesters ago was working on making slippers for elderly people. That was his master's thesis. And he gave his presentation on designing slippers for elderly people and what are the constraints that you're worried about. And he knew about it, he was passionate about it. And hey, I'm an elderly person myself, so I learned something, right? That might be useful to me. No issue, pardon me?
Did you keep in touch with them? Because I know what you're talking about.
Yeah, I know I haven't. But I did buy some deer foams at Costco last week, so
He was an
we'll
interesting
see.
kid, he really was.
Yeah, okay. No issue with collusion. I'm supposed to tell you that, okay? About what you will get in trouble with if you collude with one another. I don't care if you talk to each other, okay? It's okay. Okay,
Be sure that when we're engineers working in the field, you'll be fluent.
yes,
Get good at it.
we're not gonna try to teach you what you shouldn't do when you get out of here. Evaluate on your presentations and participation in attending presentations. Your presentations are due as soon as possible. We'll start them in October, but no later than November 5th. okay? I like to finish the class early, and actually a number of students, when they realize they're done with the class before Thanksgiving, they're actually happy because they don't have to worry about this class along with all the others that are now dumping on you, right?
I'm the
I was-
opposite. I'm gonna take every last second.
But you don't have to do anything for him, except these other things. One-page outlines on the lecture modules you watch. These are the 3 pages of 36 lectures I talked about. And that's due the week before the end of class. And attend student presentations. We would like you to come to some of the live presentations. Dr. Jenkins was going to come here for the 6 weeks he was going to lecture, but now with the Delta virus increasing, he will probably do some by Zoom and some some live. In 2 weeks from today, he will be here for some other reason, so he'll be here. Grading, the students say they learn a lot from other students' presentations. I kind of get offended when they say they learn more. My teaching philosophy, too much of our educational approach is geared to preparing students to take tests rather than learning. You guys already know how to take tests. You wouldn't be here if you didn't know how to take tests. So I'm not going to try to teach you how to take tests. The subject isn't required for anyone except for my Navy students during the summer. So let's see what we can learn. And I have found, well, anyway, one thing, good teaching makes things simple rather than complex. Okay. And there's some techniques that teachers use all the time. And I don't remember if I have it on here or not. I don't think I took it off. But now, if you've been in the class already, you already know the answer. You've all been in a class where the faculty instructor spent the entire hour doing a derivation, right? Why did they do that? What was the purpose? I learned this is another story, but in my first year as a faculty member, I've been gone for 3 days. I came back, I had a class at 10 o'clock. I wasn't really prepared. I went to the book, there was a derivation. I'll do the derivation. It's because they didn't have time to prepare a lecture. Okay? That's the real reason they do a derivation in class. I spent that hour doing the derivation, but I swore that I'd never do another derivation in class, and I haven't. I can write down the derivation and hand it out to you. You learned algebra, you can follow the derivation. I prefer to talk about what the derivation result means in terms of the physics of what we're trying to learn. But some faculty, I mean, they accuse me of being lazy by just telling stories. But there's a method to telling the stories. You already have the tools necessary to learn on your own. Induction, deduction, extrapolation, and estimation are methods that serve you well throughout your life. I actually have a module I haven't given yet on estimation. Estimation, in my opinion, is the highest form of engineering. To be able to estimate something that you didn't have a clue what it was, what the answer was, but to come up with something, okay, that's reasonable. Okay, experts have, someone sent me this. Experts have a special talent for complicating things, but the standout genius in any field is always the person who is able to take what is incredibly complex, break it down into what is essential, and present it in a way that makes it all seem simple. Okay. So I'll give you an example of a bicycle thing. Okay. I won't name the company, but this is a $4,000 bicycle wheel. And we have a guy who lectures in the spring in this class in law and technology. He's actually a practicing lawyer downtown. And he's interested in intellectual property, and he's an MIT grad. He just enjoys being around MIT students. And so he's been lecturing in this class once every spring for the last 7 or 8 years on intellectual property. So if you're interested in a startup or something, you might want to think about taking his class, which is in modular form. You're gonna have to take something on modules. There are only 18 hours of live lectures. Okay, you gotta pick some modules. So he called me up last Saturday, and he had a wheel failure. One of these $4,000 wheels. He's a bicyclist himself. And the guy was riding he was not a professional bike rider, but he was accomplished. He was riding along and the wheel fell apart all of a sudden. He's now paraplegic. Okay. And he had had some other people look at the wheel and they were trying to figure out what had happened. This is a cable stayed wheel. Anybody know what a cable stayed wheel is? I don't know that it's a term in the art. But the Zakim Bridge over here is a cable stayed bridge. Okay, you know the Zakim Bridge with the cables coming down symmetrically. So you got a rim and you got an axle. And these two are supposed to be concentric. And in the idea of getting things lighter and lighter weight, they made the rim out of a carbon fiber composite material like a BMW i3. And they used cables for their spokes. These are most wheels use a rigid metal or some other
Stainless.
member. Pardon me?
Stainless steel.
Stainless steel, whatever. And the thing is, one of them had failed. And when we looked at it, we could tell which one failed in tension. There were two others that had failed in bending. Well, you don't fail in bending unless the one in tension failed first. Okay, so we knew this one had failed first. We had some others just pulled out of the carbon fiber composite. Okay. And I said, well, this is just a cable stayed system. It's unstable. For a single spoke failure. If you have a single spoke failure, what happens to the concentricity of the axle and the rim? No, all the others are like rubber bands. Okay, they just go limp. And so it's no longer concentric. And in less than one revolution, the whole thing's going to tear itself apart and you're a paraplegic. It's a catastrophic failure mode because it's cable stayed, right? And the old things, well, if I actually had, even if it was just stainless steel or whatever, there's enough rigidity to it that it's still mostly centered. Okay. This to me was just an unstable system. It was an accident waiting to happen. As soon as you lose one spoke, you lose the wheel catastrophically. That's all I needed to know in order to have a good faith basis to file suit and try to recover something. By the way, the company that makes these is no longer making them. There had been another failure where the guy broke his collarbone, blah, blah, blah. Okay. And we don't know if there have been other failures, but they decided to quit making these. It was a poor design. Okay. So you have to get it simple. And the other experts were trying to make it too complex. They were trying to get into all, this was the cable was a Kevlar fiber, and they came to me because I know something about materials. I don't know squat about Kevlar, but I know what a cable stayed structure is going to do. Okay. Keep it simple. That's the KISS principle. So here's Don Baskin's lightweighting vehicles. You can read this later. You come to class tomorrow if you like. And then Neil Jenkins will talk about respirators versus masks. And I had Steve Lyons talking about the law just because that was left over from earlier times. So anybody have any questions? Yes.
So we just need to keep track of like what days we're coming into class for either of us.
Nope, I don't keep track. We would like you to come to class. It's really dull to lecture to an empty classroom. So I used to try to front load everything and I get all my lectures done for October 15th. Because once we get off daylight savings time, it's harder for you to get up early in the morning. And the only time, well, anyway, we won't get into the story about why I teach early in the morning. I'm an early morning person, but no, you don't have to keep track. Just enjoy yourself. Study what you want to study. This is a class where you can do anything you want. You can do nothing. And I had few students try to do that. And I put in some things like you have to write these little summaries, which are useful, and you have to do a presentation. So I do have some things to separate you from one another, but I'm not trying to separate you from one another. You're separating yourselves pretty well under COVID, okay? Anyway, just have fun and enjoy yourself. I actually do have some stories that students have. I don't know if I'll be able to find it. I probably can't find it right now.
The
Uh,
recitations are part of those 26 hours or are they?
The recitations are when you'll do your presentations, by and large. Or you can, if you email me questions, I will say, like, let's say that in 2 weeks, I've had 3 students ask me questions. And I will actually prepare a special presentation. Like 1 year, some Navy students wanted to know about titanium submarines. I've been working on titanium submarines for the first research grant I got in 1977 was on welding heavy section titanium. I was involved in the Soviet Alpha sub. If you ever watched The Hunt for Red October, I wasn't involved in the movie, but I was involved in how do you build an Alpha sub. Okay, if you take my welding class, I'll tell you how they built the Alpha sub, which 25 years ago was classified, but it's not classified anymore because I've been able to see other people talking about it. Okay, but when I learned about it in 1980, it was classified. Okay. And then I went all the way up to a few years ago. I was the one who had to figure out whether they could afford to build a new titanium sphere for the Alvin submarine, you know, the research vehicle that goes down deep. And the story there is the Woods Hole Oceanographic says, oh, we can build one for $6 million. The NSF had $25 million to build one. And I looked at the way they estimated it and I said, that's ridiculous. And I came up with 16 million, okay? And that's what went into the report, okay? I was the only person out of 37 on the committee who knew anything about how to actually weld something out of titanium, okay? But the other people were all biologists and life scientists and worried about how to, oceanographers and stuff, what would they use the vessel for? I was the only one who actually had to figure out, could we afford to build it? Well, I was off by a little bit. The actual cost was 37 million. Okay. But I was closer than the 6 million. Okay. Okay. There's some reasons for that, but we could go into things like that. If you've got a question, and the questions can be anything. A couple of years ago, I think it's still on the hallway outside my office here, it's just across the hall. The Epstein matter was big on campus. You know, this guy who, killed himself in prison for, doing immoral things with young people and stuff. And MIT was somehow involved in all of this. And I said, well, look, I can't tell you what happened with Epstein, but I can tell you other stories about MIT that are maybe not as salacious as that, but are just as immoral. And so there's a presentation I did for the students. It was actually the last class that we did right before MIT shut down for COVID a couple of years ago. I entitled it Money Talks at MIT. Okay. And I gave the story of molten metal technology, which was something that in 1994, everybody said was the next new great thing. You're a nuclear engineer. They claimed they could take molten steel and throw radioactive material in it and it would become non-radioactive. Really? Woo, I'm impressed. Okay. And we had people who were worth $30 million that were administrators at MIT that were doing a town hall for Al Gore at Kresge Auditorium during the presidential race in the 1995 or whatever time period. And he just happened to put his company on the agenda. And Professor Sadoway and I called the vice president of research. We said, "Do you think this is a conflict?" "Oh, no, it's not a conflict, not a conflict." Okay. Yeah, right. Money talks at MIT. Got enough of it, you can do almost anything you want. So I don't know about Epstein, but I can tell you MIT has a history of being bought. Okay. Why are there so many venture capitalists on campus? Well, we've taught some classes on that. I've brought some people in. If you're really interested, I'll tell you why there's so many venture capitalists on campus. They're here to use the MIT name, have an initial public offering, and have your grandmother's pensions end up with worthless paper. But they walk away with tens of millions of dollars. Anyway, that's the end of class today. So I'll answer any questions. I got tenure. And I used to be the department head. I can tell you stories around here that, well, I've had to